feel like the first day of dance classes are always the most awkward, but let's talk about triangles before we talk about anything else. We have two special right triangles that help us to form the unit circle. So let's talk about them for just a second. You know, if you want to write this down, you can. You don't have to. This is a 45, 45, 90. What's the other one? There you go. 30, 60, 90. Short leg is always across from the smaller angle, right? Remember that hinge theorem from geometry? Bigger the angle, the longer the side that connects them there. So that's how I know which angle goes with what. All right, so we're on the unit circle. So every radius on the unit circle has a value of what? Y'all remember? From the center to any point on the outside of the unit circle, 1, right? Because the radius is 1, right? Okay. So, and in fact, let's not even talk about the unit circle just yet. I shouldn't say, okay, let's just keep on going forward. Oh my gosh, this is not going well. These are 1. Hypotenuse here is 1. We're going to use these created triangles to help us to find the values, the other values there, so we can have the coordinates. Do y'all remember doing this in pre-cal? Okay. So with these special triangles, these 45, 45, 90, 30, 60, 90, we have some set values. We normally would go from the leg, right, and then form the hypotenuse. So if I'm in a 45, 45, 90, which is obviously an isosceles, if this, whatever value this is, we'll call it x. What's the value of the hypotenuse? You remember? X times, y'all, yeah, square root of 2. That's exactly right. X times the square root of 2. So if I need to go backwards, if I start with the hypotenuse and I need the leg, what would that value be? What would I have to do? Well, you're going to the 30, 60, 90. But if I want to go from here to here, what do I do? Let's say I have this triangle. I know that if this is 5, this is also 5, and that tells me that this length is 5 times square root of 2. Agree or disagree? Agree? So how would you then go if I started with 5 root 2? How would you get this length? What did you do? So that's how you get from the leg to the hypotenuse. So what's the opposite of that? Divide. So to get from here to here, I divide by the square root of 2, right? Does that make sense to you? Okay. All right. So in my unit circle, whenever my hypotenuse is just 1, if I divide 1 by the square root of 2, I can't have a radical in the bottom. What happens? So it's square root of 2 over 2. And of course, these are the same. Square root of 2 over 2. We'll throw this on the circle in just a minute. But these right triangles, you really need to know how to do them backwards and forwards. They pop up a lot, especially on multiple choice questions for us. Not a lot, but they do pop up. All right, let's talk about 30, 60, 90. We are always going or making our way back to the short leg in a 30, 60, 90. So I will call the short leg x. How do you get to the long leg? What do you do? Okay, well, that's the hypotenuse. The hypotenuse is doubled. Hypotenuse has got to be the longest. How do you get to the from the short leg to the long leg? It is square root of 3. It's this length times the square root of 3. Y'all remember that? So getting backwards, no, it's okay. You always, so you go from the short leg, this one's different because they're not the same, right? So from the short leg to the long leg, you multiply by square root of 3. Double for the hypotenuse, square root of 3 for the long leg. Okay. So if I need to go backwards on any of these, remember I divide. And I always want to make my way back to which leg first? the short leg. Y'all good? Okay. So I have the hypotenuse. I need to make my way back to the, which is on the bottom. So you just divide by 2. That's exactly right. So I've got 1/2. Now that I'm at the short leg, it's easy to find the long leg. What's the value? You multiply by the square root of 3. That's exactly right. So this is square root of 3 over 2. And I hope these numbers look a little bit familiar to you because these are all the coordinates that we will have on our unit circle as we make our way through. Everybody good? All right, let's apply it to our circle. So on your circle, and I'm just going to stick in the first quadrant right here to start with, and then we will move on to the others. This radius is 1. Here's my center. Terrible. Okay, doesn't matter. Anyway, you get the picture. All right, so here you have 3 1 slices right up the middle. And then this. Do you remember the values of any of these in degrees? That's exactly right. So there's a little place there with a little degree mark. This one is 30 degrees, 45 degrees, 60 degrees. Of course, straight up, this one would be 0 degrees because it's right on the line, and then straight up would be 90. And because this is the unit circle, these coordinates are really easy to figure out. What are they? What's this coordinate? 0, 0 is here in the middle. That's your center. So this one would be 1, 0, right? Which means this one would be 0, 1. So what I'm going to do, I want to find the coordinates of this one here. And so in order to do that, I'm going to drop down and make myself a little triangle. And what do you notice about this little triangle that I just dropped down and made? That's exactly right. It's a 30, 60, 90. 30, that means this one's 90, this one's 60 because that's all the degrees left to give it, right? All right, my radius here, always 1 because it's the unit circle. I need, do you agree that this x-coordinate is the length of this leg? That's the x value. That's how far you go over, right? So if I can find the length of that triangle on the bottom, I can find the x-coordinate. Okay, well, what is it? If the hypotenuse is 1, it's a 30, 60, 90. Is that the short leg or the long leg? Long leg. So let's find the short leg first. So that's 1/2, which means this one is root 3 over 2. So what are the coordinates here? Square root of 3 over 2, 1/2. Does that make sense? Y'all ready to do the next one? Okay. What's the what? What other little lines? Oh, those are radians. We're going to talk about those in just a minute. All right, let's do the next one. Let me do it a different color so it's pretty. I have this nice 45, 45, 90 triangle, which means the sides are the same length as isosceles. The hypotenuse is, of course, what? 1 because it's the unit circle. Very good. How do I get from the hypotenuse to a leg of the 45, 45, 90 triangle? That's exactly right. We already did that earlier. What are the lengths of the legs here? That's right. Square root of 2 over 2. This one down here, square root of 2 over 2, which means the coordinates of this point on the unit circle at 45 degrees would be last one here, which is pretty easy because it's essentially this, yeah, yep. No, it's okay. Okay, across from the 90-degree angle is your hypotenuse. So that's the radius of the circle. So the hypotenuse on all of these will be 1. Right, right. Right, right. So go back to your, that's okay. So go back to this one. It's just twisted, but it's the same. Yeah. It's hot now, isn't it? See? I'm glad. I'm cooled off a little bit now. Because of here? Oh, because it's your only class, of course. You get it dropped, by the way? Is he coming? All right, let's do the coordinates on this one. Let's do the legs here. This one's better because down here is my short leg, right? How do I know that that's my short leg? Y'all can get it. It's the short side, and besides just looking short, I know because it's across from the smallest angle, right? Okay, so here, this is nice because these values are just flipped, right? So this is going to be 1/2 square root of 3 over 2. And if you form your triangle, you will see that that is exactly what happens. This one is 1/2. This one is square root of 3 over 2. So worst case scenario, I'll show you all this because worst case scenario, you're on the exam, you have a brain fart, you cannot figure out a value. You can always quickly form these triangles and find these coordinate values. And then the rest of the circle is symmetrical and should be fairly easy for you to get to from part to part. Okay. All right, so just to show you, let's click over to quadrant 2. And then I'm gonna let you fill out the rest of it, and we'll do the tangents and some radians too, though. But just to show you in degrees, here I've got a difference from 30 to 90 is how many degrees? I mean from 60 to 90, I'm sorry. 30. So another 30 clicked this way, this would be 120. 15 in between here, right? From 30 to 45. So the next one would be 135. Another 15. Say again? 150. And then here, of course, that straight line, 180. So I would keep clicking around that way, and you can finish filling that out for your degrees there. If you couldn't remember, hopefully you'll automatically remember. But if you can't, because sometimes you get stressed and you just can't remember. These values are going to be the same. I just have to worry about positive or negative if you think about these triangles. If I went, in other words, if this is 1/2, this distance is still 1/2 to get here, but I go left instead. So I'm at negative 1/2 square root of 3 over 2. How about the coordinates at 135? That's right. And square root 2 over 2. And at 150? I always tend to remember, I know what the 45 degrees are easy. The 30s and the 60s are a little bit harder, but if you look, you can tell which one goes over further. You know, square root of 3 over 2 is bigger than 1/2, right? Because square root of 3 is bigger than 1. So you know that that's the one that goes with the longer distance. Anyway, that's just my little quirky way of remembering. However you remember the best. You do you. Does it make sense now? Okay. Yeah. And you can still memorize it. I just find it helpful if you know why. That's me. Okay, let's talk about radians because radians are very important. More likely than not, they're not going to ask you what is the sine of 30 degrees. They're going to ask you what's the sine at pi over 6. So you have to know. But you could have some degrees too, so you have to know both. So how do we go? Remember, radians is just another way to measure angles, yes? Okay, so to get from degrees to radians, what do I do? Do you remember? Right. So if 180 degrees, if pi radians is 180 degrees, okay, that means 180 degrees over pi radians is equal to 1 essentially, right? And we can multiply anything by 1 and it keeps the same value. So to go from degrees to radians, I need to, and again, you probably won't do this every single time you're trying to find something on the unit circle, but if you have a brain fart, so I'm going to multiply by, what is he doing? Degrees, I would multiply by 180 over pi. Okay, so let's convert to some radians. If I have 30 degrees and I want to make it into radians, then I'm going to multiply by pi over 180. 3 divided by 18 is 1/6, so I get pi over 6. So the radians here, pi over 6. Does that make sense? I don't want y'all to get stressed and think that everything's super hard or anything, and some of y'all are like, oh my gosh, I didn't think I was gonna have to remember this. Like, you won't have to derive this every time you play. This is just a good little refresher for us to go over some pre-cal stuff. Yes, yes. How about 45 degrees? What's the radian value of 45 degrees? Pi over 4, that's exactly right. Pi over 4. How about 60 degrees? How about 90? There you go. And you can keep going around. I'm going to let you finish filling this out. That's all we'll do today is fill out this completely.
Students with the last name starting with FGHI, please report to the library at this time. If you have your device, please stay in class. Students with the last name FGHI, thank you.
How do we use it? Go ahead. I'm sorry. Ask. So, okay, so like for instance, at 30 degrees, if I want to convert 30 degrees to radians, I do 30 times, and then I multiply it by pi over 180. So, cancel the zeros out. 3 over 18 is 1 over 6. And so you get pi over 6 radians. Yeah. Why is this helpful and how do I use it? Y'all remember what we used it for? Yeah. What's the point? Besides a cool circle made out of triangles. Evaluate. Close. You're close. Trig functions, right? Remember that? I would say, what is the cosine of 30 degrees? No calculator exact value. You remember what it is? It's one of the coordinates. So if every coordinate on here, if you've got x and y, the x is your cosine value, the y is your sine value. So now, what is the cosine of 30 degrees? Square root of 3 over 2. That's exactly right. That's exactly right. Well, and right now you might be looking, but hopefully you will have it to where eventually we'll do Kahoots and stuff to try to get you past that. Yeah. Tell me when you're caught up and then I'll. Tell me what's the sine of 5 pi over 6? There you go, 1/2. That's exactly right. I didn't write it on here, but if you already made it, this is 5 pi over 6. The sine is the y value, right? Now I'm going to throw one more thing at you to remember that you may not remember, but there are 3 trig functions we talk about: sine, cosine, and tangent. That's exactly right. Do you remember what, other than opposite over adjacent, do you remember what the relationship is for tangent? It's sine over cosine. That's exactly right. Sine over cosine. And let me show you why that is. Let's use Sohcahtoa so I can show you why. Again, I don't like to just tell you stuff. I like you to understand why. Sine is opposite over hypotenuse, right? Agreed? Cosine, adjacent over hypotenuse, right? So if I divide these two, if I take a fraction divided by another fraction, I'm really multiplying by the reciprocal. So if I do opposite over hypotenuse times hypotenuse over adjacent, they cancel, and I'm left with opposite over adjacent. That's why this works, is sine over cosine. Okay, so you can take that. Remember, sine is which one, x or y? Y, so it's y over x. Okay, so we're going to do that also because tangent values are very, very important. You also have to have those memorized or be able to get them very quickly. So if I go back to my unit circle, again, I'm just staying in quadrant 1, assuming you can figure out the rest of them. I'm doing sine over cosine, so y over x. Well, what is, for this very first one, what is 1/2? Instead of dividing by square root of 3 over 2, I'm going to multiply by, so what do you get? That's right, I got to rationalize that denominator again. 1 over the square root of 3 is the same thing as, that's exactly right. So the tangent of 30 degrees, or the tangent of pi over 6, is square root of 3 over 3. And so there's not a place. There should be a place for you to write tangents. Just write it there around it. So this will be your very first homework assignment. And it's pretty easy. You're just going to finish filling out this unit circle with your sine, cosine, all the values that are there, but also include the tangent values. You go ahead. Yes, yes. Once you get this first quadrant of tangent values, they'll be the same. It'll just be a sign change. And so up at the top of that sheet, it says positive, negative, positive, negative, positive, negative. So what in the world does that mean? Well, what I'm looking at is what values are positive and what are negative here. So in this first quadrant, my sines, my cosine, and my tangent values are all positive. I have no negative values. Do you agree? Because quadrant 1, we know, is positive, positive. Right? What's positive in quadrant 2? Sine, because it's the y values. Well, that leaves cosine to be negative, and what happens to tangent? It's negative, because you got a negative divided by a negative. I mean, a negative divided by a positive. How about quadrant 3? What's positive? Why is tangent positive there? That's exactly right, because cosine and sine are both negative there. This is very handy to remember because sometimes if you just know the sign, if you just can think in your brain where a reference angle is or where a certain point is, all you need to know is if it's positive or negative, especially when we get to derivatives and sign charts and things like that. That's all you need to know is positive or negative. How about quadrant 4? What's positive? cosine, because that's the x, right? Negative sine, because that's the y, and also tangent, because I have a positive and a negative being divided. Is it all coming back to you a little bit? Okay, I'm going to let you